Hello, this is Mrs. Mitchner, and today I'm going to go over a few more problems from the 8.3 notes, from the 8.3 note packet. So get out your note packet, and we are going to be doing 5 and 6, and I think number 9 is the other one we skipped in class. So here we go. Number 5 says that we're playing a game with 2 coins. A friend invites you to play the following game. 2 coins are to be selected at random from 2 nickels, 3 dimes, and 1 quarter. The sum of the value of the coins, if the sum of the value of the coins is 10, 20, or 30 cents, your friend will pay you 25 cents. Otherwise, you must pay your friend the value of the coins. What is your expected gain per play of the game? So I'm going to start with over here with my little chart. I'm going to put my event. We got to think about all the possibilities we can get of getting 2 coins. So I'm going to think first of all, I'm going to start with my 10, 20, and 30 cents. Kind of group those together. Forgot my T. Okay, so I could have 2 nickels, and just keep in mind that's going to be 10 cents. I could have 2 dimes. Can I have 2 quarters? Looking back, no, because I only have 1 quarter. So I'm going to think about, well, getting 30 cents would be 1/4 and a nickel. So I'm going to put that down. And then what else could I have? I could have a nickel and a dime. Now if I have a nickel and a dime, that's going to be 15 cents. Now I really wouldn't have to put those values there. That's just my mental, that's for my mental record. And then I could also have, let me see, what else do I have left? 1/4 and a dime, and that would be 35 cents. Okay, now I didn't want to put that as my payoff or my profit because I'm not getting 10 cents, 20 cents, or 30 cents. So I'm going to put my payoff right here. And remember in the problem it said that if you got 10, 20, or 30 cents, your friend would pay you 25 cents. So my payoff here is 25 cents for the first 3 because I put my 10, 20, and 30 cents there. And then it said if I got 15 cents or 35 cents, I must pay my friend the value of those coins. So I'm going to lose 15 cents there and lose 35 cents there. Okay? So the next thing I want to do is my probability. So here's my probability column. Maybe I should not put that there yet until I figure out how much space it's going to take. Okay, for the probability I want 2 nickels. So how many nickels do I have to choose from? I'm probably going to do here combinations over combinations. I don't want to do a big tree diagram. So I would have combination of 2 choose 2. How many total coins do we have? 6. So in the denominator I'm going to have 6 choose 2. So I'm going to save us a little time. Already know those numbers. It's 1 over 15. 2 dimes, combination 3 choose 2 over, wait, did I have 3 dimes? Let me double check. Yes. Over combination of 6 choose 2. 3 choose 2 I know is 3. 6 choose 2 is 15. Then I have 1/4 and a nickel. So I have 1/4 to choose from. And I have 2 nickels to choose from. And I still have combination 6 choose 2 here. So that's going to be 2 over 15. Now keep in mind if I'm going too fast, you can just ask the sub to hit pause for everybody to get caught up. Next one I need a nickel and a dime, so I have 2 nickels to choose from, pick 1. I have 3 dimes to choose from, pick 1. All over combination 6 choose 2. And 3 choose 1 is 3, 2 choose 1 is 2, so that's going to be a 6 over 15. Then I have a 1/4 dime. So I remember I had 1/4 and 3 dimes. I pick one of each of those. So on this type of problem, as long as you do your 6 choose 2 one time, you can see that you just keep repeating that. So that's 3 over 15. I want to double check, does the sum of that probability column add up to be 1? So I get 1/15 3/15, 4, 6/15, there's 12/15. Yes, I got it. Okay, so then I can finish my column there. And the last one is a product, the product of the previous two columns, I mean. So if I multiply 25 times 1 over 15, I'm going to get 25 over 15. 3 times 25, I get 75 over 15. 2 times 25, I'm going to get 50 over 15. 6 times 15, that's going to be a negative, so I get a negative 90 over 15. 3 times 35 is 105. Okay, so then I'm going to add that column up, that last column, add it all up. And again, don't reduce those denominators of 15, so you can just add up their numerators. 25 plus 75 plus 50, and then subtract 195. I got the sum of that, my expected value, to be negative 45 over 15. Now, if that looks like you can reduce it, you can. That is actually negative 3. Now, I did my column for my payoff in cents, so I can expect to lose 3 cents per game. Okay, there's number 5. And I just wanted to do that one with you just because of the actual value back here. This is what I think is interesting, is the values right here are not really used in the problem for the first three, the 10 cents, 20 cents, 30 cents. So you just have to really be careful about reading the problem. Okay, let's move on to number 6. Mr. Richmond is producing an outdoor concert. He estimates he will make $300,000 if it does not rain and makes $60,000 if it does rain. The Weather Bureau predicts the chance of rain, the probability of rain, is 0.28. So the probability of no rain is going to be 0.72. Part A. What are Mr. Richmond's expected earnings from the concert? So I'm going to make my little chart here. My event, what could happen in this particular problem? Well, it's either going to rain or no rain. Now I think next is my payoff. If it rains, Mr. Richmond is only going to make $60,000, and if it doesn't rain, he's going to make $300,000. Probability, just fill these in from above. Rain is 0.28, no rain 0.72. And then I need to multiply these two together. Okay, so now we're ready to multiply our payoff times our probability. So I'm basically multiplying 0.28 times 60,000. Now, when you do this, remember we're not going to be able to use a calculator, at least not with these problems. I just have to worry about taking 28 times 6. So I get 48 there, 12 and 4 is 16, and then I add 1, 2, 3, 4 zeros. 1, 2, 3, 4. Now, remember I have 0.28, so basically I'm going to move the decimal 2 places over, so those last 2 zeros are going to cancel out. So looking at that, I really have 1, 6, 8, and then 2 zeros. So 16,800 is what I get for that when I multiply that out. So practice doing this without a calculator, because on your test you're not going to have a calculator, and you should be able to multiply these numbers out. This next one I'm just going to worry about taking 72 times 3. So when I do that, I get 216. Whoops. And then 1, 2, 3, 4, 5 zeros. But I multiplied 0.72 times my 300,000. So this was 0.72 times 300,000. So I'm going to move the decimal 2 places over because I have 2 decimal places. So I'm going to have for my final answer there 4216 and then 3 zeros. So I have 216,000 for that number. Okay, so there's my little scratch pad I can just erase. Now for my expected value, I'm going to add those two together. So my expected value. When you're doing this, just a reminder, because we can get sloppy, is oh, my old computer is getting all these little pop-ups. Okay, so I want to line up my digits. So I have 80061. Okay, so I get 232,800. So 232,800 is what I can expect to make on that concert. That would be in dollars. Okay, so just practice using your brain instead of a calculator on these problems so you'll be ready for your test and quiz. Okay, part B gets a little bit tricky, and this is really why I wanted to do this one with you. We have an insurance policy. So an insurance company is willing to insure the concert for $150,000 against rain for a premium of $300,000. If he buys this policy, what are his expected earnings from the concert? Okay, so we're going to start over again. We have our event. We either have rain or no rain. Now, we have to think about our payoff. And this is where you have to kind of think about everything coming into play. Now, if it rains, do you remember in the problem we would make 60,000? Yeah, 60,000. Okay? But if we have an insurance plan, that means that if it rains, the insurance company is going to pay us 150,000 because it rained. But you also have to remember that you had to pay a premium. Every year you have to pay a premium for your insurance, or maybe it's every 6 months. It just depends on your policy. But this one probably is a yearly or a season. We have, or maybe it's per concert, you have to pay $300 or $30,000 for the premium. So let's kind of review that again. You get $60,000 for the profit of the concert if it rains. Since it rained, the insurance company is going to pay you $150,000 because it rained. But remember, before you even started the concert season, you had to pay $30,000 for that insurance policy. So I had to subtract that from my profits. So I add the $60,000 and the $150,000 and subtract $30,000. And I get a total of $180,000 for my payoff if it rains. Now, if it doesn't rain, remember earlier we had, in the last problem, we were told that we would make $300,000 if it did not rain. Well, you still had to pay for your insurance policy. Even though you're not collecting, you have to pay a premium. So I need to subtract $30,000 from that. So my final profit or payoff, this could probably be thought of as profit because I'm subtracting my premium. So it doesn't really matter if you think of it as payoff or profit. It's kind of the same idea. You have to be adding and subtracting some items depending on the story problem. But this one, for no rain, I could expect to make $270,000. Now my probabilities are still the same. For rain, I have 0.28, no rain, 0.72. So in this one, I'm going to take my 0.28 times my 180,000. And again, just worry about taking 28 times 18, add in your 4 zeros, and then move it 2 places to the left because of the 0.28. I got 550,400. That's what I got for that one. Down here I'm multiplying 0.72 times my 270,000. And again, just worry about multiplying 72 times 27, add in 4 zeros, and then move your decimal 2 places to the left. I get 194,400. So my expected value is to add those two together, 50,400 to 194,400. 400. Oops. So I get my expected value to be 244,800. Okay, so let's make this stand out a little bit. There's my expected value. Okay, so the big question is, part C, based on expected earnings, should Mr. Richmond buy an insurance policy? Well, with the insurance policy, he's making $244,800 for the expected value. Without the insurance policy, let's make that one a little fun too. Without the insurance policy, he was making $232,800. So as you can see, it's into his benefit to buy the insurance policy. So letter C, yes. Yes, buy the insurance policy based on the expected values. There it is. There's number 6. Okay, one more problem in the notes that I want to go over is number 9. Number 9 says, on 3 rolls of a single die, you will lose $10 if a 5 turns up at least once, and you will win $7 otherwise. What is the expected value of the game? Okay, so I got to think about this. I'm rolling my die 3 times. So here's my event. And I'm paid off by the number of 5s that I get. So let's think about this. I could possibly get 1 5. If I get 1 5, then I get 2 non-5s. That's one event. Or I could get 2 5s, and then I would get 1 non-5. Okay, and this event is just to kind of help us keep track of what our payoffs are going to be. I could also have 3 5s. That means 0 non-5s. Or I can get no 5s. Okay, so those are my events. Okay, let's think about payoffs. Reading it again, it says you will lose $10 if a 5 turns up at least once. So each one of these, here's 1 5, I lose $10. It did not say $10 per 5, it just said if a 5 turned up, I was losing $10. But if no 5s show up, I would gain $7. So there's my payoffs. Okay, now this is rolling a single die 3 times. So if I think about my probabilities, I'm thinking a binomial probability. So if I'm thinking of getting 1 5, I'm going to do, of my 3 tosses, 1 5 is going to show up. The probability of getting a 5 is going to be 1/6. That's to the first. And then I have the probability of not getting a 5 is going to be 5/6. And that's going to happen twice. For the next one, I would have combination. I want 2 5s to show up. 1/6 is now to the second. 5/6 is to the first. And then the next one, if I have 3 5s showing, I would get combination 3 choose 3. 1/6 would be to the third. And 5/6 would be to the 0. So I really wouldn't have to put that one if I didn't want. Combination for the next one, no 5s. 3 choose 0. 1/6 would be to the 0. So I know that's going to be a 1. I really did not have to put 1/6 to the 0, but I'll put it to make sure that we're all clear. And then 3 non-5s. That's 5/6 is going to be to the third. So it would probably take me a little bit of work here to figure these out, because I'd have to figure out what 6 cubed is, basically. So let's see what I have for numbers here. For the first one, I got 5 squared times the 3 out front. This is my 5 squared times that 3 out front. I would get a 75 in the numerator, and then I have to figure out what is 6 cubed, and I know that's 216. So right here, my 3 choose 2, that's a 3 times 5, so here I'm going to get a 15 over 216. This is 3 choose 3 is 1. My numerators are just going to be 1s over 216. And then this last one here, 5 cubed is 125, 3 choose 0 is 1, so I get a 125 over 216. Yes, I would expect you to be able to do that without a calculator. Okay? So I have no more room. Darn. I need to squeeze in my probabilities. Okay? I don't have room to put another column for my product, so I'm going to just do it down here. My expected value is going to be taking negative 10 times 75 over 216 plus negative 10 times 15 over 216 plus a negative 10 times 1 over 216 plus, where am I at? Lost track. A 7 times 125 over 216. Okay? So when I multiply all that out and add them together, I'm going to get a negative 35 over 216. Now, I could get out a calculator to kind of figure out how much money that actually is. And this is going to be negative 0.16. Now, you got to keep track of the fact that we use everything in terms of dollars. So on average, I can expect to lose 16 cents per game. So the expected value of the game is just negative 0.16. Now, if you don't have a calculator on a test, put in your units, negative 35 over 216. Either one of those would work. Okay? So those are 3 more problems that I just thought would be a good idea to go over. Now, what I'd like to do is go over some homework problems. If you had no questions on homework, you can go ahead and just start working on the worksheets that I have supplied for you to work on today. And, you know, if you kind of keep one ear tuned in, maybe I'll do one of the problems that you had questions on. These are problems that I know that you will have questions on, at least somebody in the classroom will, because they've got just little tricks to them every now and then. The first one I'm going to do is number 13. And number 13, it says, in a raffle, 1,000 tickets are to be sold at $1 each. The first prize is $100. There's 3 second prizes of $50 each. By how much does the price of a ticket exceed its expected value? Okay, so when I look at this, I'm going to set up my event as I can either get a first place ticket, I can get a second place ticket, or I can get nothing. Okay? Now, if I get a first place ticket, I'm going to get $100. Second place ticket, they said there are $50 tickets for those. And if I don't get drawn at all, then I've got nothing. All right? So if I think about this, and again I'm doing the payoff method, my probability, the probability of getting a first place ticket, they said there's only 1 in the basket to draw out. But my second place ticket, there's 3 sitting in that basket. And then how many losing tickets are in the basket? Well, if there's 1,000, I've already had 4 indicated. It would have 996. Okay? So when I multiply these out, I get 100 over 1,000, which is just 1 over 10, which is 0.1. Or I can get 150 over 1,000, which is 0.15. Or 0 times anything is just 0. So my expected value here of this game is going to be 0.1 plus 0.15, which is 0.25. But now think about this. It wants to know How much does the price of the ticket exceed its expected value? The expected value is 25 cents. So now you got to look back in the problem and see how much did you pay to play the game. You paid $1, so you subtract $1. I'm going to have basically lost 75 cents. So the price of the ticket exceeds the expected value by 75 cents. Okay? I love these fun little things. There's answering the question that was being asked in the problem. How much does the price of the ticket exceed its expected value? The expected value was 25 cents. This is what we had to find first, was what was that expected value. Then we had to subtract $1 from it. Okay? Next one, which other one did I pick out? Number 17. Number 17. Okay. Two teams have played each other 14 times. Team A won 9 games and Team B won 5 games. Okay, let's stop right there. The probability of Team A winning is, let's see, what was that again? 9 out of 14. The probability of B winning is going to be 5 out of 14. So that's good to write down. Okay, they will play again next week. Bob offers to bet $6 on Team A, while you bet $4 on Team B. The winner gets the $10. Is the bet fair to you in view of the past records of the two teams? Okay, so I'm going to set up my table. And I have an event. Either B is going to win or A is going to win. Okay, I'm actually going to do this using the profit method. Now you have to think of this in terms of you. You are playing this game. If B wins, if I look here, let's look at this again. They will play again next week. Bob offers to bet $6 on Team A, while you bet $4 on Team B. So you're picking Team B to win. So you got to think about this. Visualize this. There's $10 on the table. You put in your $4. Bob put in his 6. So if Team B wins, you get the $10. But you have to remember, you paid $4 to play the game. So you think you get your $10 minus what you paid to play. Your actual profit is $6. Okay? So subtract what you paid to play. If Team A wins, Bob gets all the money. That means you've lost your $4. Now think about that again. Does that make sense? There's $10 on the table, but you put in an initial $4. So if Team B wins, which is a team you're betting on winning, you're only going to profit $6. But if the other team wins, you're going to lose the $4 that you put down on the table. Alrighty. So then our probabilities are listed above. This is going to be 5/14 for Team B winning and 9/14. So when I multiply the product, which is, I think I said M times P, that's going to be 30 over 14 minus 36 over 14. My expected value is I add that up. So I get negative 6 over 14. If you want to reduce that, it's a negative 3 over 7. So we could write this out. The expected loss is $3 or 3 over $7, whatever that is. I don't have a calculator, so I can just leave it like that. So the game is not fair to you. Okay, it would be favorable to Bob. Okay, there we go. Now always put in your units here so we know, are we talking dollars or are we talking cents? So make sure you put that in so you can keep track of that. Okay, number 19 is one that sometimes we get tripped up on, so I want to talk to you about the little trick on number 19. Number 19, Sarah draws a card from a deck of 52 cards. She receives 40 cents for a heart, 50 cents for an ace, and 90 cents for the ace of hearts. If the cost of the draw is 15 cents, should she play the game? So we got to figure out if this is going to be a fair game or not. So I have my event. The events are, just listing them the way they came, I get a heart, I get an ace, and more specifically I have an ace of hearts. Now, this is what some people forget. You also have none of the above. It's possible to get none of these. None of the above. I'll just write it like that. Okay, I'm going to use a profit method on this. Now here's the trick. You could, oh no, that's not where the problem's going to be. Let's go ahead and figure out the profit. For a heart, I'm going to get 40 cents. But I paid 15 cents to play the game. So if I take 40 cents minus 15, what's my profit? Profit is 25 cents. Okay, and I don't know if you want to use cents or dollars. I'm going to use, I don't know, I guess I'll use 0.25. How about that? It doesn't matter. Okay, for an ace, I get 50 cents. So I'm taking 50 cents minus my 15 cents that I paid to play the game. So I'm going to get a profit of 35 cents. Ace of hearts gets the most money. I get 90 cents. And I got to think about that. Subtract 15 cents of what I paid to play the game. So I'm going to get 75 cents for my profit. Everything else, if I don't get one of those special things, I just lose what I paid to play. So I'm losing 15 cents. Okay, here is the trick. So if you're not paying attention, pay attention now. Probabilities. How many ace of hearts are in my deck? Well, there's only one out of 52. So I'm going to put that probability in first. And we're only drawing one card, so I don't have to worry about anything else. I can just do a straight fraction. So if you have a real specific card, always find that probability first, 1 over 52. Now go back to aces. How many aces are in the deck? Well, we all know there's 4 aces in the deck. But I've already taken out the ace of hearts. You get a special prize for the ace of hearts, so you don't want the ace of hearts included in the probability for your aces. Same thing for hearts. I have 13 hearts in my deck, but my ace of hearts, I don't want included in the hearts because I got a special prize for that one. So I have 12 over 52 for that. So that's the trick on this one, is that probability of the hearts, the ace, and the ace of hearts. You just have to take the ace of hearts out of the probabilities of getting a heart and the probability of getting an ace. Okay, so I have to add these up and subtract from 52. I get 36 out of 52 for everything else. Okay? So then you can finish this out. Here I would get 3 out of 52 for my product. Here I'd get 1.05 out of 52, 0.75 out of 52, and then negative 5.4 out of 52. Add them up. The correct answer for that one, and I'm sure you saw that one in the back of the book, E of x is negative 0.6 over 52. We usually don't leave the decimals with fractions, so I'd probably write that as negative 6 over 520. And let's see what that decimal is. 6 divided by 520. On a test, you can leave it like that. Mine's rounding, so I get negative 0.0115 if I were to get a calculator out and figure that out. So your expected win per game is negative. Let's write that out. Expected win per game is negative 0.0115. Therefore, the game is unfavorable to the player. Moral of the story, do not play this game. Okay, let me double check my math up here. If I take 3 plus, I'm going to double check and make sure I got the right answer. Negative 0.6 over, yep. All right. Just wanted to double check that. Divided by 52. Yep. And this was all in dollars, so we got to keep that straight. Did I put $1? Oh no, I did not. So I should put $1 on there. Okay. Now let's see if I had another one picked out. I know this is getting a little bit lengthy, but this will help you in the long run. Oh, number 27 is another one of those insurance problems. And maybe you'll be able to have better luck with this now that we did that problem in the notes. So if you want to try it again and check with this later, you can. Okay, I'm going to go ahead and do this. And if you want to pause it and try number 27 and then come back, and then I'll explain how you did the problem and make sure that you got it right. A 20-year-old male purchases a 1-year life insurance policy worth $250,000. The insurance company determines that he will survive the policy period with probability 0.9986. In Part A, if the premium for the policy is $450, what is the expected profit of the insurance company? Okay, so I'm going to do this by profit again. So I have two events. The person will die or they live out throughout the insurance policy period. Okay, so if the person dies, what happens is that the company, okay, now I got to see who to write this for. It says, what is the expected profit for the insurance company? So it's real important to know when you're writing these equations, are you writing this in terms of the company or the person, the policyholder? So this one wants to know in terms of the company, so we're going to do profit. Okay, so if the person dies, the company pays out the life insurance policy to the family, but the person had to pay the premium. So when I think about that, the profit seen by that company is the negative $250,000 plus $450. So that company is actually losing $24,950. $249,550 is the amount of money that the company is losing. If the person lives, the company has gained $450 for the premium that the policyholder has paid, but they didn't pay anything out. So that's all there is. So the key on this one was knowing to subtract the $450 from the $250,000 to understand that the company would lose $249,550. Okay, probability. This was given in the problem in Part A that, right before Part A. Probability that the person lives is 0.9986. Subtract that from 1. The probability that the policyholder dies within that period of time is 0.0014. So I'm going to multiply this out. That's my product. Is negative 349. I used a calculator, I'll be honest. And 449.37. So if I can look at this real quickly, we see that the expected value is going to be $100. So the company can expect to gain $100 per policy that they sell. Okay? Oh, let's do stars. There we go. Okay, I think that is all the problems that I have selected for you. So if you have more questions, the sub has my answer key to the homework, so feel free to ask for that. As you're working through the worksheet, you can feel free to check with each other, work with each other, and again, I left my solutions to the worksheets if you need to check those with the sub as well. Just ask the sub to check a particular problem if you want to see it. And have a good day, and we'll see you next class period.